Next problem, vectors number 3. What is the resultant vector? That is our answer, what we're going to look for. From the addition of the force vector, what is the resultant vector from the addition of the force vectors r? I don't think we need an r, right? Just get rid of that. 3.8 times 10 to the power of 8 newtons at 20 degrees and 6.4 times 10 to the power of 6 newtons at 75 degrees. So usually I write all of my vectors in one x and y like coordinate, but I'm going to actually separate these two because I said in another video, but like vectors, they can get messy. So my first x and y, it's going to be for the first force. And I want to clarify that this is going to be positive x. This is positive y, right? This is what we're going to look at first, right here. First, it's at 20 degrees, so it's pretty low, maybe something like that. So we know that this line is 3.8 times 10 to the power of 8 newtons. I'm going to call this F1. And now I'm going to make another coordinate for F2. F2 is at 75 degrees. So if positive x is 0, positive y would be 90, right? So it's kind of like somewhere in between there. 75, like that. That's close enough. And this is going to be our F2. And this is 75 degrees. I should have clarified in our first vector too that this right here is 20 degrees. Okay, and just to visualize the final answer, we have our another clean coordinate, and we start at the origin and we go this way, right? And then from here, like I said, vectors are always like start to finish, start to finish. So we start here, and then we go here, and then we have another force. So we're gonna start right here again. Imagine you have like your imaginary xy, where you're like starting from the origin again, and then we're going 75 degrees from here. Those are the addition of the two vectors. So our final resultant vector should look like start to finish, something like that. That is our answer that we are looking for. So how do we find that? We find that by getting the x component of this force, Fx, and the y component of this force, Fy, right? We can use that equation, really simple one, c squared plus a squared plus b squared. C, of course, would be our final f, and our two other sides are fx and fy. But we need to find what fx is. We don't know that yet. So how will we find that? That will just be the sum of our x component forces, right? I'm going to write that here. Fx is going to be the addition of f1x and f2x. Let's find f1x. So we have our hypotenuse f1, and we're looking at only the x component. So starting from the origin, that'd be this, f1x. And since this, can you guys understand that that'd be cosine? Can I just say 1 cosine 20. If that doesn't make sense, you should go to vectors number 2. I think I kind of like explained it a little more deeply right there. So that would be our f1x, right? So it'd be f1 cosine 20 plus, I'll just keep it in red, f2x, the x component of f2. It's right here, and then it goes to here, f2x. And just like the first one, that'd be using cosine. So I can call that f2 cosine 75 degrees. F2 cosine 75 degrees. What was F1 again? F1 was this, and F2 is this. So I'm just going to write that down. F1, 3.8 times 10 to the power of 8 cosine 20 degrees plus F2 was 6.4 times 10 to the power of 6 cosine 75. Now calculate that, and I believe you should get something like 3.6 times 10 to the power of 8 newtons. So that is our fx. We just found what this is, right? So we're one step closer to finding our hypotenuse resultant force. We need to look for Fy now. It's the same thing though. Let's do it in blue. Fy is just the sum of the y components of all the forces here. F1y and F2y. Okay, let's look at F1y. We start here. This is our hypotenuse. So we are traveling just this in the y direction, right? So we'd be using sine. I'm going to call this F1y equals F1 sine 20 degrees. I don't know if I should explain this or not, but like how I know it's sine is because we have a triangle like this, right? Imagine we have this and this. Doesn't that look like the cursive S? So that's how I know it's sine. For f1x, we had this and this. That looks like a C, right? So I know it's cosine. And if we had this and this, that'd be like T, right? Cursive T. So if it was these two sides that I knew, I'd be using tangent. That's how I kind of think about them. Do what works for you. So we found what F1y was, right? It would be F1 sine 20. Now let's look for F2y. So we start here. We went x over, and now we're going to go y up. Pretend these touch, and that's going to be F2y. So we have our angle right here. We have our hypotenuse in here. That looks like cursive S, right? So I know it's going to be F2 sine 75 degrees. F2 sine 75 degrees. And then F1 is 3.8 times 10 to the power of 8 sine 20 plus F2 was 6.4 times 10 to the power of 6 sine 75. Oh, okay, 75 5 degrees. Put that in your calculator and you should get 1.3 times 10 to the power of 8. Okay, we found our Fy. We found this. So now we can plug these two. I'm going to call this like equation number 1. We can plug this into number 1 and this into number 1, right? But again, before I do that, I want to get rid of the squared on the f. So I'm just going to take the square root of both sides. So it becomes fx squared. Come on. Fx squared plus fy squared. And now, oops. Now I'm going to put in the values that we found for fx, which was 3.6 times 10 to the power of 8 squared, plus fy was 1.3 times 10 to the power of 8 squared, all in the square root. If you put that into the calculator, it should come up like 3.8 times 10 to the power of 8. That is this, right? That is this. And are we asked to find the angle of, are we asked to find the angle right here? Maybe. We'll just find it. So, again, we have a simple triangle. We know all the sides, but we're just looking for the angle. That means that you can use cosine, sine, tangent, whatever you want. It doesn't make a difference because you're going to get the same answer anyway. I'm just going to use tangent this time. So I'm going to say that, oh, and I'm going to call this angle theta. So I'm going to say that tangent of theta is going to be fx under fy, right? Because cursive t there. And we are looking for the theta. So I'm going to take the inverse tangent tan. My mouse is, or my pen is acting up. Fy fx tan -1 fy was 1.3 times 10 to the power of 8. Fx was 3.6 times 10 to the power of 8. Is that correct? I think it should be. And the angle comes out to be something close to maybe 19.8 degrees. So, yep, those are our two answers.